Mm, Assalamu alaikum students. Now we discuss some more examples of implication. Today, first of all, we will discuss about nebula implication. Nebula implication. A nebula implication is a map. A nebula implication is a map. And map is again from 0 1 square to 0 1 interval of the form x nebula implication y is equal to eta of x nebula y. If this is the main formula of nebula implication. Here eta is negation, that means eta of x is equal to 1 minus x, and nebula is T cono. It can be any T cono. Now we solve it with some examples. First of all, we will take example 1. If we take x nebula y is equal to max of xy, or it can be written as max of xy, or we can say that x max y. Now we find the nebula implication x nebula implication y. It will be equal to eta of x nebula y, and eta of x means 1 minus x nebula y, so it will be max of 1 minus x comma y. So this will be our answer. This will be our formula for nebula implication. Now we go for the example 2. If we take x nebula y is equal to x plus y minus xy, then this nebula implication x to y is equal to again its formula is eta of x nebula y. This will be equal to 1 minus x nebula y, and now we apply this formula for this T cono. We will get 1 minus x plus y minus 1 minus x into y. We will get 1 minus x plus y minus 1 minus y plus xy. Now y is cancelled with each other. We will get 1 minus x plus xy. So this is the formula for nebula implication. Now we see the third example. Example 3. Here in example 3 we will have x nebula y is equal to 1 min of x plus y. Here the Nabla implication is equal to, we find it, we see that we will get, it will be eta of x nabla y, or we can write it 1 minus x nabla y. So it will be 1 and 1 minus x plus y, or we can write in this way that it is min of 1 and 1 minus x plus y. This is the formula for it. Similarly, we have, if we apply this nabla on 0 and 1, we will get again the same table, and we will see that 0 nabla 0, it is 1. We apply this formula here, you can do it, it is very simple. And 1 nabla implication 1 is again 1, and similarly 0 implication nabla implication 1 is again 1, and we can solve it, and we see that if we apply 1 implication to 0, then it will be again, here we can solve it 1 eta of x nabla y, so we get eta of x, that means 1 minus 1 nabla 0, it will be 0 nabla 0, answer will be 0. Similarly, we can solve the others, and these all will be 1. Now we see one more example of it. In this example, we can see that if we have g of x is equal to e raised to power minus x square, and eta of x is equal to 1 minus x square under root, then our answer will be x implication y is equal to 1 if x is less than equal to y, and 1 minus x square plus y square under root if x is strictly greater than y. If we solve it, we see that x implication y is equal to eta of x nabla y if we see that, if we apply it here, we will find that formula, because we have the function g of x, we apply g here, we will find that we get g inverse of g of eta of x, or 1 minus x, we can write here 1 minus x, and g of y union g of 1. It will be g inverse of g of eta of x and g of y. We know that eta of x is equal to 1 minus x square under root. We apply here g, we will see that it will be under root 1 minus x square, and for g of y it will be e raised to power minus y square union g of 1, it will be e raised to power minus 1, because g of, if we apply here g of 1 will be e raised to power minus 1 square, that means e raised to power minus 1. Now we x implication y is equal to g inverse of, if we add these two numbers, if we see that if we sum up these two, we will get e raised to power minus 1 minus x square into e raised to power minus y square union e raised to power minus 1, and we can write it g inverse of e raised to power minus 1 plus x square minus y square union e raised to power minus 1. Here we see that we find the function g inverse. Since we know that y is equal to e power minus x square, if we take log on both sides, then log of y is equal to ln of y power minus 1. ln of y is equal to minus x square. ln of y is equal to minus x square. So x square is equal to minus ln of y, and x is equal to this minus will be go on the power, and we will get ln of y power minus 1 under root. So we apply this x here, here we find the value of g inverse. This x is our g inverse. We apply a g inverse, we will find that this is separate calculations. We will apply here, and we will see that we will get ln of exponential of e raised to power minus 1 plus x square minus y square power minus 1, and these are both are power, so it will multiply with minus 1 because this is the power of exponential and we are taking minus 1 is multiplying with it, and whole of the power 1 by 2 or under root. Similarly, we get ln of e raised to power minus 1 into minus 1, and whole of the power is 1 by 2. We will find that will be ln of, we see that ln and e are inverse to each other, so these two will cut each other, and we will get minus 1 plus x square minus y square into minus 1 whole of the under root union. Here log and e again cancel each other, and minus 1 to minus 1 we will get 1 power under root, and this will be, we apply minus 1, we multiply here, we will get 1 minus x square plus y square union 1. So this is our answer. So here we can see it is 1 if x is less than equal to y, and 1 minus x square plus y square under root if x is greater than y. So this completes the theorem. Thank you very much.